Hello there, welcome to this video. Today we are going to solve contextual problems involving exponential equations, and we will use our practice and knowledge of logarithms, the exponential inverse, in order to solve these questions and give an answer to a story problem or a word problem. For prior knowledge, here we have the question: solve the equation 4000 equals 500 e to the power of 0.025x. Give the exact solution and the approximate solution to 3 decimal places. So just a reminder, with exponential equations, the main thing in order to undo an exponential, you need a logarithm. So you're going to have to isolate your exponential. So I want to get that e by itself. So what we're going to do, we're going to divide both sides by 500. And what we get is 8 is equal to e to the power of 0.025x. And now, in order to undo the exponential, we'll go ahead and take a logarithm. Now, because it's base e, I'm going to be very, very specific. I'm going to take the natural log of e of both sides. So what we get is the natural log of 8 is equal to 0.025x times the natural log of e. And we know that the natural log of e, right, that's just 1. That essentially cancels out. This is what we do, common convention. But I just want to remind you that the natural log of e is actually 1. So that comes down in front, right? And, that essentially gets absorbed. And now I'm going to solve. We'll divide by 0.025, divide by 0.025. And we get x is equal to the natural log of 8 over 0.025. Okay, this is your exact. This is what we call an exact solution. And then your rounded approximated value, I believe, is not here. We're going to have to go ahead and calculate this. Let me adjust this window for us right here. Okay, that's better. So here's my calculator. I'll go ahead and add calculator, and I want the natural log of 8. So I'll hit Control Divide to get a fraction. Natural log of 8 over 0.025. Okay, and they wanted it to round it to approximately 3 decimal places. So I'll look at 1.77, and we're going to round the 6. So 0.178, 83.178. So 83.178. Okay. All right. Okay, steps in order to solve an exponential equation. What you're going to do first is you need to write the equation as a single power on each side. Then you'll go ahead and take a common log or a natural log. It doesn't matter which one you do. I mean, obviously there's times where I want to use the common log, right? If I'm working with an exponential that's base 10, or a natural logarithm if I'm working with an exponential that's base e, but it doesn't matter which one you use. Then we'll use the power property. We'll bring down that exponent out, the variable, right? That's where we want to solve for. Bring down that power out of the logarithmic argument. We'll solve using algebra, approximate if necessary, and then we'll state the solution to the exponential equation, and then interpret it in terms of context. And what's very, very important that we do here is that we go ahead and we use units in this case. We need to make sure that we use units, okay? All right, so let's go ahead and look at an example. All right, an investment example. Here we go. Okay. It says Emily deposits $250 into an account that pays 4.5% compounded quarterly. The formula A equals P 1.01125 to the power of 4t gives the amount A in the account after t years for an initial investment P. So I highlighted 250 here. That's what we call in investment the principal, or in this case, the initial amount. So you'll notice here they talk about an initial investment P. That's $250. They talk about the 4.5% compounded quarterly. If you remember back from our Unit 8 when we were looking at exponential functions, that's going to go inside of the base, and you can kind of see that structure compounded quarterly. It's to the power of 4t. that part's already done for you. So thankfully we don't have to do any of that. Okay. Now we do have a value a. This represents the amount in the account, and then we have a variable t up here. That is t years. Okay. So part A, they're going to start asking us questions about this prompt. What is the balance of the account after 8 months? Well, they want us to find A. We don't know what A is. They say, what's the balance of the account? And then they say, okay, after 8 months. So here, T is equal to 8 months. Well, this is a problem because in the units of the prompt, it's T years. So I want to convert this to years. So I want it to be a year. So I'll use good old stoichiometry to convert. Okay, so we have 8/12, which is the same thing as 2/3 of a year. Okay, so 2/3 of a year, right? Our months cancel. All right, so let's go ahead, and this one, it just seems pretty straightforward. They're going to ask us to compute. So A, the amount in the account is equal to the principal, 250 times 1.01125 to the power of 4 times 2/3. 4 times 2/3, okay? So I am going to enter this into my calculator. If you have a TI Inspire like I'm using, this is a pretty fancy calculator, top end, then that's great. It easily enters it. Some of you, if you're using a TI-30, you're going to have to be careful about reducing or approximating these values, okay? So watch your values. Make sure you get the same answers as me. If you don't have one of these, I would recommend going to Desmos.com. Desmos has a great calculator, and if you click Math Tools right here, you can see just a scientific calculator. And has a lot of the functions that you'll want to use here. Okay, so if you're looking for a calculator. All right, so let's compute this. We have 250 times 1.01125 to the power of 4 times 2/3. 2 divided by 3. Okay. So we get 257.57. 257.57. Okay. So we'll say after 8 months, Emily's account will be worth or have in it $257.57. Okay? All right, here's where we get into the meat of what we're doing here. We want to go ahead and find out some questions using inverse of exponentials, which is logarithms. So part B, it says here, how long will it take in years and months for the balance in the account to double? Balance in the account to double. So here, I don't know what time is. I don't know what that is. They want us to find. That's how long. But they do want the account to double. So how much is that? You have to think about that one. They're not just going to give it to you. So if we start out with 250, that is 500. Okay, so our equation now becomes, I want the account A to be 500. I'm starting out with 250 times 1.01125, and I'm raising it to the power of 4 times t. And I got to solve for t. Okay, I want my exponential by itself. So let's go ahead and divide both sides by 250 to cancel out that coefficient. So we get 2 is equal to 1.01125 to the power of 4t. And then here, in order to bring down this exponential, here's where we use a logarithm. Am I going to use common log or natural log? Does not matter. I don't have a base kind of telling me what I should do. So natural log of 2 is equal to 4 times t times the natural log of 1.01125, okay? And now, in order to isolate t, I'm just going to divide by everything that is multiplying with t. So 4 natural log of 1.01125. And that is it. That is it. Okay? So here's our exact answer. T is equal to natural log of 2 over 4 natural log 1.01125. Naturally to us, that doesn't mean anything, right, if I'm talking about time, but we can plug this into the calculator. So natural log of 2 divided by 4 natural log of 1.01125. So let's plug this in. We get 15.4897. Okay, so this is in years. That's very, very, very important. This is in years. 15.4897. So they said in the prompt, how long in years and months? How long in years and months? So I know for sure 15 years. I know this is 15 years. So we can say it will take about 15 years. And then now they want months. They say around to the nearest month, years and months. So what I'm going to do is I'm going to take away this down here, the t. This is in years. This is in years. So I'm going to take away 15, and that's going to leave 0.48975, yada, yada, yada. And I need to go ahead and take this years, and I need to convert to months. So 12 months, right? And I'll cancel the years. Okay, so we're going to take our value. Let me subtract 15. Okay, let me move myself over here. We get 0.489, okay, and I want to take that value, and now I want to go ahead and multiply. I'm going to multiply by 12. So we get 5.8 rounding to the nearest month. That is going to be 6 months, about 6 months, okay? So this is approximately 6 months. All right, so going back up here to our answer, it will take 15 years and 6 months about for the account to double. Okay, so here is the next example. It kind of mirrors that one. Here's a practice problem. Please go ahead, pause this. I want you to answer these 2 questions relating to this example. I'll go ahead and show the solution here in a moment. All right, hopefully you went ahead and paused me. In this example, they again say the balance in the account earns 2.3 annual % interest compounded semi-annually and is calculated according to this formula. A equals P times 1.0112T, where P is the initial investment and T is in years. So they say here, determine how much time in years and months it will take for our investment of $5,000 to reach $7,500, round to the nearest month. Well, I'm just going to set up that similar to what we just did. 7,500 is equal to 5,000 times 1.011. No 2, it's just 115 to the power of 2t. So if you went ahead, you divide by 5,000, I believe that gives you 3 over 2 equals 1.0115 to the power of 2t. And then what we did is we take a natural log. So you have the natural log of 1.5 is equal to 2t natural log of 1.0115. And then you get t is equal to the natural log of 1.5 divided by 2 natural log of 1.0115. Okay? Now, we do want that to be in months and years, or sorry, years and months. So if we go here and show this one, you should have gotten 17 years in about 9 months. 17 years, 9 months. Now notice the printed answer here, they used common log. So if you use common log, you should have gotten the same answer. You don't have to use natural log. Okay, and then part B, it says if the account is closed after 9 years, how much will the investment be worth? Well, again, here's where we just take the time that they give us, t equals 9 years, and we plug it in. So 5,000 times 1.0115 to the power of 2 times 9. So you plug that in, and the solution that you should have gotten was 6,142.65. All right. Okay. Example number 2. Here, AJ made a steaming pot of stew. When the temperature of the stew reached 70 degrees Celsius, AJ turned the stove off, and the stew began to cool. The temperature T, measured in degrees Celsius of the stew, m minutes since AJ turned the stove off, can be modeled by the function T of m equals 20 plus 50 times 10 to the power of negative 0.4 m. Okay, so something important, they say the temperature T, measured in degrees Celsius, that's this right here. So T of m, that's the temperature of the stew based upon m. And they say m, this is minutes since AJ turned the stove off. So m, it's minutes since AJ turned the stove off. Okay, so there's our formula. Part A says, how long to the nearest minute did it take for the stew to reach a temperature of 45 degrees Celsius? So I don't know what T, or what, in this case, m is. That's how long. I'm not sure how long. And then what I do know is they say the temperature, they want the temperature to reach 45 degrees Celsius. So I just plug that in. I'm going to use the equation 45 equals 20 plus 50 times 10 to the power of 0.04 m. Okay, play the game. Isolate m. So I want my exponential, here's the important part, right? Your exponential base to be by itself. Exponential base to be by itself. So we'll subtract 20. Reverse order of operations. Reverse order of operations. So we get 25 is equal to 50 times 10 to the power of negative 0.04 m. Okay, divide by 50. And we get 1/2 is equal to 10 to the power of negative 0.04 m. Here's where I want to use a specific logarithm. I have base 10. You better use common log. Common log. Now, the reason for this is, right, is that I have log base 10 here. So those cancel out. They cancel out, right? Just like in our prior knowledge where we took the natural log of e. So those cancel. Okay, and I'm left with log of 1/2 is equal to negative 0.4 m. And if I want to solve for m, I'm just going to divide by negative 0.04. Okay, so let's take this. We'll plug m into our calculadora. Why did I put 0.2? I was thinking 1/2. Negative 0.04. Okay. So there's m. I want to find this in context. What is this approximately? And they said round to the nearest minute. So I'm going to look here. Let's go. Okay, log of 0.5 divided by negative 0.04. Okay, notice I'm leaving the log base blank. That's just log 10, automatically log 10 if you're using a TI Inspire. Here we get 7.525 rounding to the nearest minute. That's going to be about 8 minutes. About 8 minutes. Approximately 8 minutes. Okay, so we can say here it will take about 8 minutes for the stew to cool to 45 degrees Celsius. That's pretty fast if you ask me. Okay, there you go. All right, part B. What is the temperature of the stew to the nearest degree after 5 minutes? Well, hey, all I'm going to do is evaluate at 5. That's pretty straightforward. So 20 plus 50 times 10 to the power of negative 0.04 times 5. So we'll go to our calculator. We will plug this in. 20 plus 50 times 10 to the power of negative 0.04 times 5. Boom. Okay, and we get about, to the nearest degree, it's going to be about 52 degrees. 52 degrees, approximately 52 degrees Celsius. Okay. The temperature of the stew after 5 minutes is about 52 degrees Celsius. Not too bad, not too complicated. And that one, they always give you a solving one and then an evaluation one. Solve and then evaluate. Solve and then evaluate. Okay, here is an example. I would like you to pause me. I want you to go ahead and try this one. This is a fun one. It says in one part of the atmosphere where the temperature is constant, negative 70 degrees Fahrenheit, pressure can be expressed as a function of the altitude by the equation P of H equals 128 times 10 to the power of negative 0.0682 H. Whew. Where P is the atmospheric pressure. So P, notice that's your output. P, this is our output. And the unit is kilopascals. That's pretty sweet. Kilopascals. KPA. That's new. And then H is altitude. H is altitude in kilometers above sea level. Altitude, if you're not familiar with altitude, some of my students trip up on that word. That's just height. That's how tall something is. Altitude. It's like you're in a plane, and you're thousands of kilometers or feet, meters above sea level. Okay. So anyway, go ahead. Please answer these two questions, and I'll show you the solution here in a moment. All right, hopefully you went ahead and tried this. Here is the solution to part A. They say find the altitude to the nearest tenth of a kilometer for a pressure of 2.55 kilopascals. So 2.5, that's your output. You're trying to solve for H, which is your altitude. So divide by 128. Take a logarithm of each side. Okay, common log cancels, and then you're just going to divide by negative 0.62. And you end up getting H is equal to log of 2.55 divided by 128 divided by negative 0.0682, which is approximately 24.9. And that's kilometers above sea level. Okay, so there's your answer. And then B, what is the atmospheric pressure at an altitude of 18 kilometers? Well, hey, all you do is plug in 18. Compute, you should have gotten 7.58 kilopascals. Did you write the sentence? Did you include units? Sweet. All right, that's going to do it for this video. This will be a part 1. I have a couple more examples and practice ones for you to try. I'll catch you in the next video. Like, subscribe, watch this one, watch that one. See you guys later.